Hello everyone, welcome to another problem solving session with me, Abhijit Rai. Now, this is a word problem which 30% people get wrong. However, an important part about word problems is that they take a lot of time to actually solve. So in this problem, one of the main things we are going to focus on is how to minimize calculations to save time. When you're seeing word problems like this, what are some of the things that you should notice, and how would you end up reducing calculation to make the calculations manageable in the exam? And I will also point out what you shouldn't do to keep the calculations manageable in the exam. We are also going to look at the statistics formula, which formulas to apply for solving this question. And finally, we are going to talk about how to find the minimum and maximum value using the tricks we already know from one of my previous videos. And I will also give you the link to that video so that if you are not aware of these tricks and techniques, then you can go back and review those tricks and techniques. Before we go any further, I am very sure you are going to find a lot of value from this video. And if you find this video helpful, please do not forget to like this video and subscribe to my channel, and I will keep bringing in more such videos for you. Alright, so let's get started. One of the first things you have to do when you're solving a problem which has a median is to arrange things in a ascending order. Now you could arrange them in descending order and it is absolutely fine. However, just remember that by training we are told that things are in always ascending order, right? 0, 1, 2, 3, 4. So there is an order in our mind and it is easier to think of things when they are in ascending order. So let's look at the question and start breaking it down. We are given 7 pieces of rope. They have an average of 68 centimeters and their median is 84 centimeters. And we are also given this relationship between the longest piece of rope and the smallest piece of rope. And let's read it so that we get the relationship right before we start solving the problem. So we are given that the longest piece of rope is 14 centimeters more than 4 times the length. So first let me write the 4 times the length of the smallest piece. Let S be the smallest piece or the smallest length, and it is 14 more than the 4 times smallest length. So the largest length would be 4S plus 14. Okay, with that, let's start writing this down in ascending order. Let's draw the 7 pieces of rope. Now this is the smallest and we know that this is the largest, and the measurement of these two I already know, right? And I need to maximize this. This is what the question is asking. What else do I know about this? I know that the median is 84 centimeters, and since there are 7 ropes, the middle point would be the median, which is the 4th point right here. This would be the median, and this is 84. We don't know anything about these two and these two. However, we are also given that the average of all of these is 68, which means the sum would be 68 multiplied by 7. The average will be sum divided by 7 because there are 7. So sum will be average multiplied by 7, which is 68 multiplied by 7. Now I'm going to take a pause here and talk about saving time. Now look at some of these things. I am looking at 14 here. I'm looking at 7 here. I'm looking at 84 here. One thing that you should immediately notice is all of these are multiples of 7. So I have a choice here. I have a choice of multiplying 68 by 7 and marking it as 476, or keeping it at 68 multiplied by 7. And my instinct is to keep it, because if I am dealing with multiples of 7, eventually there is a likelihood that the 7 cancels off. However, you are still going to be able to solve the question if you multiply, but it is going to cost you so much time that it would be unbelievable. And this is my first recommendation. When you are trying to solve GMAT problems, try to keep the calculations till the last step where it starts becoming unmanageable, and cancel out the common factors rather than calculating upfront. Calculating upfront would often add time to your problem solving and also cause issues. This is not something that is applicable only to this question. I have a similar problem from official guide that applies the same concept, and the link to that problem is above and also in the description of this video. please take a look at that question as well. So let's continue. Let's call these two numbers S1 and S2 and these numbers S3 and S4. We are given the sum of the 7 ropes, S plus S1 plus S2 plus 84 plus S3 plus S4 plus 4S plus 14. Now I'm going to put it in the brackets because this is one length. This is the maximum length, equals 476. Now you have to understand a couple of things here. If I have to maximize the maximum length, and maximum length is a multiple of S, I have to maximize S as well. So I'm going to keep this S right here and take everything on the other side of the equation. So my equation becomes 5S plus 14 equals 476 minus 84 minus S1 plus S2 minus S3 plus S4. Now to maximize the small s, what I have to do is minimize these. Right, and this is from the maximizing and minimizing strategy video. If you have not seen that video, the link is above and also in the description. Once you understand the maximizing and minimizing strategy, it is very easy to follow. All I'm saying is 5s max would be equal to 476 minus 84. I'm bringing the 14 here as well, minus S1 plus S2 minus S3 plus S4. And since I need to maximize this, I need to minimize this. So this is where the next step of statistics concepts come into the play. What is the minimum possible value of S1 and S2? Remember, these were in ascending order, but not necessarily unequal. Remember, these are in ascending order but not necessarily unequal, so these could be equal. What is the minimum value of S1? The minimum possible value of S1 is nothing but S, because it could be equal to S, and we are not given that these rope sizes cannot be equal. So it is possible that they could be equal to the smallest length. So S1 minimum equal to small s. Similarly, S2 minimum is same, which is small s. Now, can they be smaller than small s? They cannot be smaller than small s because small s is the smallest size of the rope. If they were smaller than small s, then they would be the smallest size, and then all our equations will break. So their minimum size is just s. Now, S3 minimum, as you can see very clearly, S3 minimum would be the last known quantity on its side, on its left side, which will be 84. If S3 is smaller than 84, then 84 cannot be the median. So S3 has to be either equal or greater than 84. Hence the minimum possible value of S3 is 84. And similarly for S4, the minimum value would be 84. I'll take a pause here and make sure that you understand it. If you are not able to understand and follow something, please leave a comment. I personally respond to all the comments on my videos. So if you are stuck somewhere or something is not clear, please feel free to put a comment. So now let's substitute these values. So as you recall, I said I don't want to actually calculate it as 476. If I had done it, it would cause me a lot of calculations. So I'm going to put it back as 68 multiplied by 7 here, minus s minus 84 minus 84. I'm going to rearrange this equation a little bit, take the two s's on the other side. So 7 small s equals 68 into 7. There are 3 84s here. So I'm going to write this as 3 multiplied by 12 multiplied by 7. If you recall, I had said one of the patterns I'm noticing is that all of these are multiples of 7. Now all of that is coming to a fruition. If you see, we have 7 here, we have 7 here, we have another 7 here. Let's not forget about this 14. So that is 7 into 2. Now we can easily cancel off the 7 because 7 is common here, and we have s equals 68 minus 36 minus 2. That means s is 30, which implies by this formula that L would be 134. Answer is D. As you saw, there was a very strict regimen I followed, which was not to really do the calculations beforehand and wait till the end to actually save time on the calculation. If I had ended up keeping 476 as is, then I would have to calculate 84 multiplied by 3, subtract all of them, and my subtraction would be a big deal as well. And in the end, I would have gotten the same result, but would have spent a lot more time in the calculation. So this is one of the most important tips of this question, how to actually reduce the amount of calculations. And as I said, there is another OG problem where you can practice the same thing in the description below. It is not on a statistics, so that you know that this kind of calculation philosophy applies to other topics as well. So in terms of key takeaways for this particular problem, first thing you have to do is learn statistics formulas. If you are not aware of statistics formulas, then this problem would be very tough to solve. And also, when you see the median, always try to arrange them in ascending order. Any order is fine. Ascending order is more preferred and recommended because our mind is primed to think about left to right ascending order. Second, there is a way to minimize calculations. You just have to practice it. And the recommended way is to keep the calculations till the last. The more you are able to see the factors of a certain number, the easier the calculation are going to become towards the end. And finally, it is really important to understand the minimizing and maximizing strategies. They are not that difficult. However, if you don't know them, it will add additional time to logically reason out everything while you are solving in the exam. It is a very short video. Again, the link of the video is in my description. Please take a moment to go through that video and get better at it. I hope you found this video helpful. If you have any questions, please let me know. I personally respond to them. If you found this video helpful, don't forget to like this video and subscribe to my channel. I will really appreciate it, and I'll keep coming back with more problem solving techniques. All the best with your preparation.